Hello everyone, welcome to the class. Today we'll discuss your question paper for JEE Mains. So here we have first question. So this is the first question we have. So the value of this determinant is equals to m, and minimum value of this determinant is denoted by small m and maximum is denoted by capital M. Now we have to find the value of capital M power 4 minus a small m power 4 over here. Okay, that's how we have to solve it. Okay. So now in that case, we can find the value of L. We can expand it. Okay. To try to solve it, first of all, here, what we can do to find it. So we can subtract your row 1 from row 2. Okay. So that's how we got minus 1 over here, 1 and 0. Correct. Similarly, if I subtract row 2, row 3 to row 2, so in that case we got 1 over here and 1, and we have sin square x cos square x 1 plus sin 4x. Okay, so that's how L is equals to minus 1 into 0 minus cos square x minus 1 into minus 1 into 1 plus sin 4x minus sin square x. Okay, and here we have 0, so we don't need to expand it, and this is equals to L. So now in that case L is equals to, we can write cos square x. Here we have cos square x, and we have minus 1 minus sin 4x and plus sin square x. So for cos square x plus sin square x, we got 1 over here, 1 and minus 1. Okay. Okay, give me a minute for this. Here we have 1, here we have 0. And in that case we got 0, 0 minus cos square x. We have minus 1 over here. Correct. And here also we have minus 1. We did a mistake over here. Here also we have minus 1. So for that case, this is plus cos square x. Okay. And for minus 1, we can write it, this is plus sin square x. Okay. So for that case, because we have negative sign, so this cos square x is become negative. This minus 1 minus your cos 4x and minus sin square x. So that's how we can take minus cos square x and minus sin square x equals to minus 1 sin 4x. Therefore we can write minus 2 minus sin 4x. So because we know that the minimum value is minus 1 and maximum value is 1 over here. Okay, if I take minus 2 over here, this is equals to minus 3. Okay, and again if I take minus 2 over here, this become your minus 1. Okay, so as you can see here, the minimum value is minus 1 and the maximum value is 1. So if I take minus sign over here, so we need to change the sign for minus sin 4x. So the maximum value is 1. Okay, here the minimum value is minus 1 and maximum value is 1. Okay, so again if I like multiply with minus sign, so we got this condition. If I take minus 2 in all the sides over here, so we got minus 1 minus 2 minus sine 4x and minus 3. Okay, so that's how we can say that minus 1 is the maximum and minus 3 is the minimum value. Correct. So we can say that L maximum is minus 1, L minimum is minus 3. So capital M is minus 1, small m is minus 3. Now we have to find m power 4 minus small m power 4 in a mod. So minus m power 4 minus minus 3 power 4. So we got 1 minus 81. This is equals to minus 80 in a mod, and here we have 80. Okay, so answer is 80 over here. Option C is the correct answer over here. Okay. In the next question, if a variable takes the discrete value, if the variable takes the discrete value over here, then the median is, okay, so as you can see, this is in order, this is in decreasing order, as you can see over here. So we have to put in overall in a increasing order. Here we have decreasing order, then we have increasing over here. So we have to write in a increasing order. So we have alpha minus 7 by 2, then alpha minus 5 by 2, then we have, sorry, alpha minus 7 by 2, alpha minus 3, then alpha minus 5 by 2, then alpha minus 2, after that alpha minus 1 by 2, and after that alpha plus 1 by 2, and alpha plus 4, alpha minus 1 by 2, alpha plus 1 by 2, alpha plus 4, and alpha plus 5 over here. Okay, that's how we can write it in an increasing order. So in that case, we have to find the median over here. So median is equals to, we have 1 2 3 4 5 6 7 8, 8 terms. 1 2 3 4 5 6 7 8. Okay, we have total 8 terms. Okay, so in that case, middle terms are 1 2 3, fourth and fifth term are middle term. So we can write alpha minus 2 plus alpha minus 1 by 2 and whole upon 2. This should be the median over here. Okay, so this is the fourth and fifth term. So now in that case, we can write 2 alpha minus, this is 5 by 2 whole upon 2. So we can write alpha minus 5 by 4. Okay, alpha minus 5 by 4. Option A should be the correct answer over here. Okay, you can check the solution from here. Next question we have, if cos inverse x equals to pi plus sine inverse x. So we can write cos inverse x in terms of sine. So pi by 2 minus sine inverse x equals to pi plus sine inverse x plus sine inverse 2x minus 1. Then find the sum of all the values of x. Okay, so for that case, we can write minus pi by 2. Okay, and it is equals to 2 sine inverse x plus sine inverse 2x minus 1. Okay, now in that case, we have minus pi by 2 over here, and here we have 2 sine inverse x, sine inverse 2x minus 1. So we got a negative value. Therefore, we can say that x should be lesser than equals to 0 and x should be lesser than equals to your 1 by 2. This is two condition over here. Okay, so if I try to like intersect this to your interval, so in that case we can say that overall we can say that x should be lesser than equals to 0. This is the condition over here. Okay, and now if I try to put the values over here, x, if I put x equals to 0 over here, or x, if I put 0 over here, we got 2. sine inverse 0 plus sine inverse minus 1. Therefore, sine inverse 0 is overall 0 and sine inverse minus 1 is equals to minus pi by 2. So for because 0 for 0 we got your minus pi by 2. Okay, so for that case here we can't take the value lesser than your minus 1, correct? As we know that for sine inverse x the value is in between minus pi by 2 to pi by 2. Okay, and the value of x should be in between minus 1 to 1, correct? So we can take value lesser than 0 but we can't take lesser than your minus 1. Okay, so if you put any other values you will not get your minus pi by 2. Yes, suppose if I put minus 1 over here, if I put minus 1 over here, suppose, so for that case we got 2 sine inverse minus 1, okay, and plus here we have sine inverse minus 3, which is not possible, correct? Because if I put sine minus 1 over here, this got your minus 3. This is not possible. Okay, so if I put any value lesser than 0, we got the value lesser than minus 1. So it's not possible. So we can't take any value lesser than 0. So it not satisfy the condition. So we only can take, so only solution is x equals to 0 over here. In the given question, they have asked for the sum of all the value of x. So it is equals to C, option C, 0. Okay. In the next question, the letters of word Radhika are permuted and arranged in alphabetical order. As in English dictionary, the number of words that appear before the word Radhika. Okay, number of words that appear before Radhika. Okay, so for that case, what we can do here, we have to find the word Radhika over here. We have words over here. We have A, like we have A 2 times. Okay, we have A 2 times. Then we have D, and then R. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, we have 7 letters. So now, if I take, first of all, if I take A over here, okay, so we have 1, 2, 3, 4, 5, 6. We have 7 spaces to write. Okay, so therefore, we can take 7 factorial over here, but A is repeated, okay, 2 times. No. Here, we because we have using A over here, so for that case we can take, yes, we can take your 6 factorial. Yes, we can take your 6 factorial, and we can take another A, okay, in any of these places. Okay, so overall we can say that this is equals to 6 factorial equals to 720. Next word should be over here is D. Okay, because A is same for both the cases, so we can't take other permutation for A starting with A over here. So let's talk about D. Okay, so if I talk about D also, 1, 2, 3, 4, 5, 6. We have 6 places. Then we can take 6 factorial, but we have 2 A's, so we have to divide with 2 factorial. Okay, this will happen 4 times, like because for D, for H, for I, and for K. For all the cases, we have to take 6 factorial upon 2 factorial, 6 factorial upon 2 factorial, 6 factorial upon 2 factorial. Okay, so overall we can write 4 into 6 factorial upon 2 factorial, and this is equals to, we can write, we have 4, here we have 2 times, so this is 1440. Okay, next talk about R. Okay, let's start with R. So we need Radhika. We need a word Radhika. Okay, to find the word Radhika, first of all, if I take RA over here, before D there should be A according to alphabetical order. So we have 1, 2, 3, 4 spaces. So we can take 4 factorial over here. Okay. So after A, in the third position after A, we have to take D over here. Okay, we have to take D over here. So now in that case also we have 1, 2, 3, 4 spaces. So this is 4 factorial, and Radhika belongs in between this. Radhika belongs in between this. Now what we can do here, so we need to take all the words in between this 4 factorial, which means 24 words. Okay, and we have to find out the number of like word, or we have to find the alphabetical order of the word Radhika. So we need to take D. After that we need H. So just take H. After that we need I. After that we need I over here. So this is I, R, A, D, then H, then I, and then we need to take K over here. Okay, K. Now we have two places. Okay, so here to making it Radhika, no no no, I did a mistake over here. Okay, we forget about A also, we have another A also. So in that case we have to take A over here. So we have 1, 2, 3 places. So this is 3 factorial, because we have to take RADA. Okay, after that we need to take after A we need to take another like letters over here. So we need to take here RA and then DA. Okay, so RADA are fixed. Okay, and we have 3 places. So this is we have to write in 3 factorial after A. Okay, I have using RA and D. After A we have to use your H, correct? So for that case RA, D and H. Okay, and for H, after H we have, this is 24 and this is 6. Okay, so after H, if I take H, we have to first use which letter? We have to first use A over here, correct? So again we need to use A over here. Then we have 2 factorial. Then we have to use 2 factorial. After that we have RA, D, H. Because we have already used the letter A. So after that we can use any other letter also. So it should be I. Okay, and after that, because we have using I over here, we have 2 places again. Okay, so after I the first letter should be again A. Okay, so it should be again A. So again we have to take 2 factorial, correct? But in this 2 factorial we have 2 letters. So first letter is what? Radhi, A and K, and another one is Radhi, K and A. Okay, so this one is 1 and this one is 1. So we have to find the number of words that appear before the Radhika. So let's find out. So here we have, let's try to find out it. So we have 720, 1440, then 24, okay, then 8, and after that 1. So 2193. Okay, so we have total 2193. Therefore 2193 words before Radhika. Okay, so 2193, option A should be the correct answer over here. Now in the next question, we have A and B are given, and that's how we have to find the relation between these two. So first of all, for A, we have 99 power 15 plus 100 power 50. Therefore, we can write 100 minus 1 power 50 plus 100 power 50. 100 power 50. So in that case, we can write 50C1, okay, and then 50C0, 50C0, 100 power 0, correct, and 100, let's take 100 over here, 100 power 50, 50 minus 0, and minus 1 power 0, correct. Then if I take minus 1 power 1, so that's how we got minus sign over here, and 50C1, 100 power 49. After that we got plus sign, 50C2, 100 power 48, and so on, 10 plus 100 power 50 over here. Okay. For B we have 101 power 50. This is equals to 100 plus 1 power 50, and now we can write 50C0, 50C0, 100 power 50 and 1 power 0 plus 50C1, 100 power 49, 1 power 1 plus 50C2, correct, 100 power 48, okay, till we have to take till we can write 50C50 and into 1 over here. Okay, now let's compare both. Okay, so after comparing over here, as we can see, we have 100 power 50 over here and 100 power 50 at the last. Okay, but in between we have minus 50C1, minus 50C2, minus 50C3, and so on. So we have to subtract many values over here. So after that you can conclude that B should be greater than A. Okay, so option B should be the correct answer over here. You can check the solution. Next question we have question number 56. If cos alpha plus cos beta equals to A, cos sin alpha sin beta equals to B, and we have to find cos 3 theta upon cos theta. So this is your equation 1, this is your equation 2. Taking a square of equation 1 and add it with equation 2. So we can write cos square alpha plus cos square beta plus 2 cos alpha beta, it is equals to A square sin square alpha plus sin square beta plus 2 sin alpha sin beta, it is equals to B square. Okay, so if I add both, so in that case we'll get sin square alpha plus cos square alpha plus sin square beta plus cos square beta plus 2 into cos alpha cos beta plus sine alpha sine beta, it is equals to a square plus b square. Okay, so for that case we can write 1 1 plus 1 is 2, 2 plus 2 cos a cos b plus sin a sin b, it is equals to cos alpha minus beta, and this is equals to a square plus b square. Now alpha minus beta is equals to 2 theta, so we can write 1 plus cos 2 theta, it is equals to a square plus b square. Now 1 plus cos 2 theta is equals to 2 cos square theta, it is equals to a square plus b square. Correct. So for that case we can write 4 cos square theta, it is equals to a square plus b square according to the question. Now in that case we have to find cos 3 theta and upon cos theta. Correct. So for that case we can write 4 cos cube theta minus 3 cos theta and upon cos theta. Therefore 4 cos square theta minus 3, it is equals to a square plus b square minus 3. Correct. So a square plus b square minus 3, option B should be the correct answer. In the next question we have limit x tends to 0 under root 2 plus x minus under root 2 upon x. So here we can write it under root 2 plus x plus under root 2 upon under root 2 plus x plus under root 2. So therefore we can write x tends to 0. Here we can write 2 plus x minus 2 whole upon x into under root 2 plus x plus root 2. Both cancel out. Okay, after that x is also cancel out. And if I taking limit over here, we can write 1 upon under root 2 plus 0 and plus under root 2 according to substitution method. Okay, and we have 1 upon 2 into root 2. Okay, so option A should be the correct answer. Okay, next question we have the possible value of p we have to find for which graph of the given function does not lie below the x-axis, where x belongs from minus pi by 2 to pi by 2. Okay, so for that condition let's take tan x equals to t. So here we can write f of x equals to 2p square minus 3p into t plus t square plus 1. Okay, so in that case this expression looks like this. Tan x equals to, here we have I have putting it tan x equals to t, so it change from f of x to f of t. So for that case we can write it t square minus 3pt plus 2p square plus 1. Okay, so therefore we can say that it does not lie below the x-axis. So the condition should be d should be lesser than equals to 0. So we can write b square minus 4 into a into c. It should be lesser than equals to 0. So 9p square minus 4 into 2p square. So we can write it 8p square and minus 4 lesser than equals to 0. So p square minus 4 lesser than equals to 0 over here. So for that case we can write p square lesser than equals to 4. So we can write p belongs in between minus 2 to 2. According to this question they asked for the possible value of p for which the graph of function is you are below the x-axis. So for that case the p should be lie in between minus 2 to 2. So here 0 is lie between minus 2 to 2, 3, 4 or 8 are not lying. So option A is the correct answer. In the next question, if Z is any complex number satisfying this condition, then which of the following is correct? Okay, the condition is Z is a complex number. This is equals to 1 over here. So we can write Z minus 1, mod Z minus 1 is equals to 1. So we can write Z minus 1, it is equals to mod Z minus 1 into cos theta plus iota sin theta. Okay, as you know that. So for that condition, we can write z minus 1, and this value is equals to 1. So we can write cos theta plus iota sin theta. Now z is equals to 1 plus cos theta whole into plus iota sin theta. Okay. Now z is equals to 1 plus cos theta plus your iota sin theta. Okay. So in that condition, we can talk about the argument of z. Okay. So here we can write 1 plus cos theta is 2 cos square theta by 2 iota into 2 sin theta by 2 cos theta by 2. So for that case, z is equals to 2 cos theta by 2 into cos theta by 2 plus iota sin theta by 2. Okay. Z is equals to 2 cos theta by 2 into cos theta by 2 plus iota sin theta by 2. Okay. So now in that case, what we can do here, we can say that the argument of your z is equals to theta by 2. Here as you can see, argument of z is equals to theta by 2. Therefore, we can write theta is equals to 2 into argument of z. And as you know that theta is the argument of z minus 1. So we can write argument of z minus 1, argument of z minus 1, it is equals to 2 into argument of z. Okay. So this should be the condition over here. This is the condition. Okay. So here your option A should be the correct answer. In the next question, the mean of the number is 6 and the variance is 6.80, then which of the following gives the possible values of A? So as we know that summation of x minus x by square upon n is equals to variance. So therefore we can write A minus 6 square plus B minus 6 square plus 8 minus 6 square, 5 minus 6 square plus 10 minus 6 square whole upon, we have 5 terms, it is equals to the variance 6.80. Now we can write A square plus B square minus 12A minus 12B plus 72 plus 4 plus 1 and plus 16, it is equals to 6.80 into 5. Now we can write A square plus B square we have to find the value of A and B, correct? Okay, currently just write it in form of simply A minus 6 square plus B minus 6 square, just write it like this. Okay, 8 minus 6 is 2, 2 square is 4, minus 1 square is 1, and your 4 square is 16. So A minus 6 square plus b minus 6 square plus, here we can write this is equals to 0, 34, 34.00, which means 34. Okay, and minus this is 21, so it is equals to 1 and 3, 13. Correct, 13. So let's check the option which should be the correct over here. We need 13 over here, correct? So if I put a equals to 0, this becomes 36. Okay, and 7 minus 6 is 1, not satisfy the condition. 5 minus 6 is 1, so we got 1 over here, and 2 minus 6 is minus 4, so it becomes 16, not possible. If I take 3 over here, 3 minus 6 is 3, so 3 square is 9, 4 minus 6 is minus 2, and minus 2 square is 4, so we can write 9 plus 4 is equals to 13. So we can put a equals to 3 and b equals to 4. That's how we can write minus 3 square plus minus 2 square. This is equals to 9 plus 4, and overall we got 13 over here. Okay, so 13 is the correct match. So option D is the correct answer. Okay. Next question we have f of x is given, g of x is given. In that condition we have to find the g of x. Then g of x is, which option is suitable. In this question we have f of x is given, g of x is looks like this over here. Okay, so for g of x we have seen that maximum of f of t is 0 to t belongs from 0 to x. Okay, so this is the condition. Let's talk about your f of t. So f of t can be written as t cube minus t square plus t plus 1, and if I take differentiation of it with respect to t, so we can write 3t square minus 2t plus 1. Okay, that's how we can write it. So for that case, let's talk about d. So we can write b square minus 4 into a into c. So here we have 4 minus 12. It is equals to minus 8. It is lesser than 0. So d is what? Lesser than 0 over here, which means this is always positive. This is always positive. Therefore, we can say that f of t is an increasing function, is an increasing function, and because it is an increasing function, we can say that the maximum value of f of t, therefore we can say that hence maximum value of f of t is at maximum of t, maximum of t, and it is equals to x. Therefore we can say that maximum of f of t is equals to f of x. Correct? Maximum of f of t is equals to f of x. So now in that case, g of x is equals to, we have to take maximum of f of t. So here we can write f of x. So we have x cube minus x square plus x plus 1. Correct? And we have 3 minus x. 3 minus x. So x belongs from 0 to 1. Okay. And x is greater than 1, lesser than equals to 2. lesser than equals to 2. Look at the options over here. It is talking about the continuity and differentiability of g of x. Okay, so therefore we can do one thing over here. At x equals to 1, we can take left hand limit x tends to 1 negative x cube x square plus x plus 1. If I take 1 over here, we can write 1 minus 1 plus 1 plus 1. 1 cancel out. This is equals to 2. Okay, talking about the right hand limit x tends to 1 positive. Okay, here we have 3 minus x, so we can write 3 minus 1, it is equals to 2. So as you can see, left hand limit is equals to right hand limit. Let's talk about the f of 1 also. So f of 1 is also equals to 2 if you try to find it. So therefore it is equals to f of 1. Okay, so continuous from 0 to 2, we can say that it is continuous. Okay, we can say that it is continuous from 0 to 2. So here the statement continuous in 0 to 2, continuous in 0 to 2. Okay, this statement is wrong because it is continuous at 1 also. This statement is also wrong. Okay, let's talk about the differentiability over here. So left hand derivative. Okay, let's talk about the real left hand derivative. So for that case, we can like differentiation of this. Okay, and we have to taking the limit x tends to 1 negative. So for that case, we can write 3x square minus 2x plus 1. So here we have 3 minus 2 plus 1. So overall it is equals to 2. Okay, after differentiating it, let's talk about the right hand derivative. So for that case, we got 3 over here. Sorry, we got minus 1 over here, and this is equals to, because differentiation of this part is minus 1, so overall we got minus 1. So here we can say that left hand derivative is not equals to right hand derivative at x equals to 1, and at other points these are your differentiable, but not at your x equals to 1. So for that case, we can say that continuous at 0 to 2 and differentiable at 0 to 1 and 1 to 2, but not at 2. Okay, so here continuous and differentiable in 0 to 2 except x equals to 1. That means it is not continuous at x equals to 1. Correct? So option B is also incorrect. Option A is the correct answer. Continuous in 0 to 2 in whole this interval, and differentiable at 0 to 2 but not 1. Okay, so option A is correct answer. In the next question, if A is a square matrix and e raised to A defined as given. Okay, now in that case we are talking about here f of x. Okay, talking about f of x and what g of x. Okay, so for that case, first of all, here we have A. A is what? A is x x x x. Let's talk about a square. Okay, so if I try to multiply it, we got 2x square 2x square 2x square 2x square. Okay, similarly, if I take a cube, again if I take a cube, so for that case also this is 2x cube plus 2x cube, though, so this is 4x cube, so we can write it 2 square x cube 2 square x cube 2 square x cube 2 square x cube. That's how we can write it. Okay, and so on. We can write like this all the values. So therefore we can say that e raised to a, it is actually equals to, if I add all the values like this, so for that case we'll get 1 plus x plus 1 plus x plus 2x square upon 2 factorial plus 2 square x cube upon 3 factorial and so on. Okay, that's how we can write it. Okay, similarly, next in the next case, this is e raised to a, correct? Give me a minute. Here we have. Okay, but for I looks like this 1001, correct? So for that case, we got x plus 2x square upon 2 factorial plus 2 square x cube upon 3 factorial and so on. Similarly here, okay, that's how we can write it. Now here, as you can see, we got e raised to x. Okay, so try to write it in this form. So here, let's try to write it e raised to a, and it is equals to, here we have, if I take 1 by 2 over here, 1 by 2 from here and 1 by 2 from here. So for that case we can write, let's take 1 by 2 common, correct? Let's take 1 by 2 common, and we have 1 plus 2x, and next we have, if I multiply 2 over here, this become 2x square upon 2 factorial. Similarly 2x cube upon 3 factorial and so on, and plus 1 by 2, correct? That's how we can write it. Similarly for here, what we can do is that we have to add 1 by 2 and we have to subtract your 1 by 2. So 1 by 2, 1 plus 2x plus 2x square upon 2 factorial and so on, and minus 1 by 2. Okay. This part and put it in this part. Okay. Now we can write it e raised to a. It is equals to half e raised to 2x and plus 1 by 2. So overall we can write it. 1 by 2 e raised to 2x plus 1. Similarly here we can write 1 by 2 e raised to 2x and minus 1. Here 1 by 2 e raised to 2x minus 1, 1 by 2 e raised to 2x plus 1. Correct. So that's how we can take 1 by 2 common. So we got e raised to 2x plus 1, e raised to 2x minus 1, e raised to 2x minus 1, and e raised to 2x plus 1. Okay. So this is a value for e raised to a. Correct. Now, therefore, we can compare f of x and g of x. Therefore, we can write, therefore, f of x is equals to e raised to 2x plus 1 and g of x is equals to e raised to 2x minus 1. Okay, we got this value. Now, we have to find the integration of f of x upon under root g of x with respect to x. F of x upon under root g of x with respect to x. That's why we can write e raised to 2x plus 1 upon under root e raised to 2x minus 1 dx. Okay. Okay, that's how we can write it. Now here I is equals to e raised to 2x upon under root e raised to 2x minus 1 dx plus e raised to 2x, sorry, 1 upon under root e raised to 2x minus 1. Okay, so for that case, let's take e raised to 2x minus 1 is equals to t. So we got e raised to 2x and we have 2 also. So dx equals to dt. So for that case, we can write e raised to 2x dx is equals to actually half of dt. Okay. So here you can write it 1 upon 2, 1 upon under root t dt. And plus here we can write 1 upon e raised to x square minus 1. For that case, we can write e raised to x over here and e raised to x in the denominator also. Okay. So we have I 1 by 2 and t raised to minus 1 by 2 dt. Okay. And plus here we can write sec inverse e raised to x and plus c. Okay. Here we have sec inverse e raised to x plus c. For that case, I is equals to 1 by 2 and t raised to minus 1 by 2 plus 1. So this is t raised to 1 by 2 and t raised to 1 by 2. Both cancel out. Plus sec inverse e raised to x plus c. Okay. So because here we have taken e raised to x equals to u. So e raised to x dx is equals to du, correct? So if you are not able to understand this, so I can write it in this form also. So it is 1 upon u into under root u square minus 1 du. That's how we can write it. So after that we'll get sec inverse u plus c. Now I hope you understand this. So for that case, we have t raised to 1 by 2 and t is basically e raised to 2x minus 1, and in place of u we can write e raised to x and plus c. So this would be the solution over here. Okay, let's check the options. E raised to x, e raised to 2x minus 1 plus sec inverse x, sec inverse e raised to x. So option B should be the correct answer over here. Okay. Now in the next question, we are asked for the value. We have to find the value of this is divisible by which of the given option. Okay. So first of all, here look at the your first row. So we can take a common. So we can write 1 1 0. Okay. A 2a plus b 1 0 a plus b 2a plus 3b. Okay. In row 2 we can use operation row 2 minus row 1. So here del is equals to a into, so 1 minus 1 0. Here we have a plus b and a plus b. 0 1 2a plus 3b. Here we have 1a and 0. Now in that case, del is equals to a into, we can write a plus b into 2a plus 3b minus a plus b. For that case, del equals to, here we have 2a square plus 3ab plus 2ab plus 3b square minus a minus b. So del is equals to, okay, we can do one thing also. We can take a plus b common. So here we have 2a plus 3b minus 1. Okay, this is more suitable according to question. Because we have asked for this is divisible by which of the current your given option. So a plus b, it is divisible by a plus b, as you can see. Okay, so yes, a plus b is the correct answer. Option A is the correct answer. In the next question we have mod of z equals to 5, then the points representing the complex number. So let the complex number represented by a is equals to minus iota plus 15 upon z. So here we can write a plus iota is equals to 15 upon z, taking it in mod. So this is equals to your mod 15 upon z. So we have a plus iota, it is equals to 15 upon mod z, correct? So for that case we can write a minus iota, and it is equals to 15 upon, because mod z is equals to 5, it is given, this is equals to 3. So we have a minus iota, it is equals to 3. Okay, so as you know that z minus z0, it is equals to a. In that condition, z0 is the center, correct? This is the center, and your a is radius of the circle. So we can say that the center is your 0 comma minus 1 and the radius is 3. Okay, so here we can write center is 0 comma minus 1, radius is 3. Option B should be the correct answer. Okay, and the next question, if the probability for A to fail in the examination is 0.2, probability for A to fail is 0.2, probability for B to fail is 0.3, then the probability that either A or B fail, okay, then the probability that either A or B fail, okay, so the probability, it should be lesser than or equals to PA plus PB. It should be always lesser than और इक्वल्स टू पी ए प्लस पी बी. भाई इससे तो ज़्यादा हो नहीं सकता ना, ये आपके पास फेल हो रहा है, ये फेल हो रहा है. इन द कंडीशन प्रोबेबिलिटी दैट इधर ए और बी फेल, या तो ए फेल हो या तो बी फेल हो, तो इसके लिए मैक्स टू मैक्स कितना हो सकता है? मैक्स टू मैक्स इट इज 0.5, बिकॉज 0.2 प्लस 0.3, 0.5. देयर इज a chance of 0.5 to fail either A or either B. So option C should be the correct answer over here. Okay. In the next question, the number of values of k for which the linear equation possesses a non-zero solution. Okay. So we have given options over here. Okay. And we have to solve it for k. So we just need to take here del equals to 0 for that condition. So we have 4k2 k41 221 and it is equals to 0. 4 into 4 minus 2 minus k into k minus 2 plus 2 into 2k minus 8 equals to 0. So therefore we can write 4 into 2 minus k square plus 2k, k square plus 2k plus 4k minus 16, it is equals to 0. Therefore we can write k square minus 8k, k square minus k square minus 6k, and here it is 8, 8 and minus 16 is minus 8, so we can take plus 8 equals to 0. So we can write k minus 4 into k minus 2 equals to 0. K is equals to 4 comma 2. Okay, k is equals to what? 4 comma 2. So the number of values of k is equals to d. Okay, k equals to 4 comma 2, 2 values. In the next question we have, if a is given where aij is the cofactor of this given element aij of matrix A, then this is equals to what? Okay, then we have to find this is equals to what. So as you know that element and its cofactor, multiplication of element and its cofactor, and we have to taking sum of all the element of same the same row, and taking all the cofactor of same row and taking a product of it and add all this product. So in that case this value is equals to the determinant. Okay, so we just need to find the determinant of A. Okay, so therefore we can write 1 into minus 5 minus 9 0 plus 2 into 6 minus 0, this is equals to minus 14 and plus 8. So this is equals to minus, no, this is no, minus 0, minus 5 minus 9 14. Okay, this is 12. So it is equals to minus 2. Minus 2, option D should be the correct answer. Okay. In the next question, we have to find the value of this. So we can write 10. Here we have cos inverse 3 by 5. So if I try to write it in 10, in the form of 10 inverse. So here we have base upon your hypotenuse, correct? So we need perpendicular. So we can write perpendicular upon base. 10 inverse 1 by 2. 10 inverse 4 by 3 plus 1 by 2 upon 1 minus 4 by 3 into 1 by 2. Now we can write 10 inverse, here we have 6, 3, 6 minus 4 upon 6, 6 cancel out, 10 inverse 11 by 2. Therefore the value is equals to 11 by 2, correct? So answer A should be the correct answer. The value of A for which the function is continuous at every points of its domain. Okay, so for that case we can write, we have to find the value of A. So we just need to take at x equals to 1, try to solve for left hand limit, x tends to 1 minus 5x minus 4. So it is equals to 5 into 1 minus 4, it is equals to 1. For the right hand limit x tends to 1 positive, here we can write 4x square plus 3ax. Okay, So for that case, this is 4 plus 3a. Okay, and because left hand limit is equals to right hand limit, according to question it is continuous at every point, so we can write 1 is equals to 4 plus 3a. So a is equals to -1. Okay, so a is equals to -1. Option D should be the correct answer. Okay, in the next question we have, if f of x equals to mod x minus 3, then we have to find first f of x is continuous at x equals to 3 and f of x is differentiable at x equals to 0. Okay, we have these two conditions. So in that case we have to find which of these statement is correct. First of all, here f of x is continuous at x equals to 3. Okay, so the graph looks like this. The graph looks like this, and this is 0.3. Correct. If I put 3 over here, this becomes 0. Yes. Okay. Now in that case, the left part of 3, it looks like this, minus x plus 3, and the right part is x minus 3. We can write f of x equals to minus x plus 3 if x is lesser than 3, and x minus 3 if x is greater than equals to 3. This is the condition. Okay, so in that case, if I try to find at x equals to 3, at x equals to 3, if I take the left hand limit x tends to 3 negative, the left side is minus x plus 3. Yes, this is minus x plus 3. So if I try to substitute it, this becomes 0. Talk about the right hand limit, x tends to 3 positive. Here we have x minus 3. If I try to substitute it, it is equals to 0. Okay, talk about f of 3. If I put 3 over here, for f of 3, it is 3 minus 3, it is equals to 0. Therefore, it is continuous. It is continuous at x equals to 3 for sure. Okay, let's talk about it is differentiable at x equals to 0. So at x equals to 0, look at the x equals to 0. Look at here. Here we have minus x and plus 3. At x equals to 0 here, this is a linear line. Okay, yes, it is a what? Linear line. So for that case, what we can do here, we can take f dash x. We can take f dash x. Okay, but we are talking about the x at x equals to 0. Okay, so here we talk about the x equals to 0 because when x is lesser than 3, the function is minus x plus 3. So we have to take differentiation of minus x plus 3. This is equals to minus 1. Okay, so let's talk about this part. So for both cases, the function is same. So here left hand derivative and the right hand derivative both are equals to your minus 1. Okay, so we can say that f of x is differentiable at x equals to 0. So we can say that option C is correct. Both your 1 and 2 statements are correct over here. Okay, next question we have to find the value. And the next question, the value of cos sin inverse 3 by 5, sin inverse 5 by 13 and sin inverse 33 by 65 here. So we can write cos sin inverse 3 by 5 plus, as you know that sin inverse x plus sin inverse y can be written as sine inverse x into under root 1 minus y square plus y into under root 1 minus x square. So therefore we can write sine inverse 5 by 3 into under root 1 minus 33 square upon 60 5 square plus 33 by 65 into 1 minus 5 by 13 whole square. Okay, so after solving it you will get, just try to solve it, you will get sine inverse 4 by 5 over here. Okay, for that case in place of sine inverse 4 by 5 we can write it cos inverse 3 by 5. Okay, so we also know that because sine inverse theta plus cos inverse theta, sine inverse theta plus cos inverse theta is equals to what, your pi by 2. So it is equals to cos pi by 2 and cos pi by 2 is equals to 0, and 0 should be the answer over here. Okay, so it is equals to 0. Okay, you can check the solution over here. In the next question, A, B, C are three complex number on unit circle mod z equals to 1, which means it satisfy the condition A, B, C should satisfy this condition also. So we can write mod A equals to 0, mod A equals to 1, mod B equals to 1 and mod C equals to 1. Therefore we can write A bar equals to 1, B bar equals to 1 and C bar equals to 1 over here. Okay, now we have another condition over here. We know that because ABC is equals to A plus B plus C, so write it A plus B plus C, it is equals to ABC over here. If I divide with ABC in both the side, so 1 upon BC plus 1 upon CA plus 1 upon AB is equals to 1. Okay, if I multiply it with B bar C bar, okay, so we can write it B into B bar into C into C bar plus C bar A bar upon C into C bar into A bar plus A bar B bar upon A bar into B bar, it is equals to 1. Okay, now because we know that B into B bar equals to 1, C into C bar equals to 1, similarly C into C bar, A bar all equals to 1, so we can write it B bar C bar plus C bar A bar plus A bar B bar, it is equals to 1. So we can write in the form of BC plus CA plus AB whole bar, which means whole conjugate, it is equals to 1. Okay, yes, I hope you understand this. So in that case, if I taking it in mod, okay, if I taking it in mod, because as you know that this is the condition that here x bar it is equals to 1. Okay, this is the basic condition over here, correct? And these are your three complex number. So overall it is a complex number. So in that case, if we're taking it in mod also, okay, it is also equals to 1 over here. Okay, as you can see. So here this is equals to 1. This should be the answer over here. Okay, you can check the solution over here. In the next question we have summation of this term, it is equals to 2 raised to 17 minus 1 upon 14. We have to find the value of n. Okay, so try to simplify it first of all. So here we have, this is NCR, R plus 1 upon R, R plus 2 upon R plus 1. So we can write R plus 1 upon R plus 1 into NCR. Okay. So for that case, summation of R equals to 0 to N, we can write 1 plus 1 upon R plus 1 into NCR. Okay. Therefore here we can write summation of R equals to 0 to N NCR plus summation of R equals to 0 to N 1 upon R plus 1 into NCR. So for that case, this is equals to what? 2 raised to N, as you know that, because if you try to write it NC0, NC1, okay, till NCN it goes, correct? Plus, for that case, we can use the identity 1 upon R plus 1 into NCR. It can be written as 1 upon N plus 1 into N plus 1C R plus 1. Okay, we can write it like this. This is the identity. So for that case, we can write it summation of R equals to 0 to N 1 upon N plus 1 into N plus 1C R plus 1. Okay. Now here, this is equals to 2 raised to N plus 1 upon N plus 1 and summation of this part. So if I write it from R equals to 0, it is start from N plus 1C 1 plus NC1 plus 2 till N plus 1C N plus 1. Therefore, we can write this is equals to 2 raised to N plus 1 upon N plus 1, and here we can write N plus 1 C0 plus N plus 1 C1 till N plus 1 N plus 1 C N plus 1 and minus N plus 1 C0. Now for that case, 2 raised to N plus 1 upon N plus 1, and this part is N raised to N plus 1 minus 1, correct? That's how we can write it. So here we have 2 raised to N into N plus 1 into plus 2 raised to N plus 1 minus 1 upon N plus 1. Okay, try to write it in this form. So for that case, we will get the value. Here we have 2 raised to N plus 1. Okay, here we have N into 2 raised to N, this is N plus 1, 2 raised to N plus 1 and minus 1. 2 raised to N plus 1 and minus 1. Did I forget something? Here we have 2 raised to N plus 1 and we have minus 1. We can take 2 raised to N common here. Let's take 2 raised to N common. We have N plus 1 over here. Okay, N plus 2. N plus 2. Then we have minus 1 upon N plus 1. So finally, we have 2 raised to N into N plus 3 minus 1 upon N plus 1. Okay, let's try to find the value of N. We have to find the value of N over here. Okay, which values satisfy the condition? So because it is equals to 2 raised to 17 minus 1 upon 14. Therefore, we can say that if I put N equals to 13, yes, if I put N equals to 13, so we got 14 over here, 13 plus 3 is 16. So we got 2 raised to your 4. So 13 plus 4 is equal to 17. Therefore, N equals to 13 satisfy the condition. Okay, this should be your answer. Okay, so for that case, we can write this is equals to 13. N is equals to 13. And this should be the final answer over here. Now in the next question, we have the value of S is equals to mu. Then we have to find mod 6 mu plus 2. Now in that case, we have S given. If I multiply with 3 over here, we can write 3 into 5 upon 1 square into 4 square plus 3 into 11 upon 4 square plus 4 square into 7 square, 3 into 17 upon 7 square into 10 square till infinite. So for that case, 3s is equals to, we can write it 4 minus 1 into 4 plus 1 upon 1 square into 4 square plus, here we have 7 minus 4 into 7 plus 4 upon 4 square into 7 square plus 10 minus 7 into 10 plus 7 upon 7 square into 10 square till infinite. Okay, that's how we can write it. 3s equals to 4 square minus 1 square upon 1 square into 4 square. Similarly, 7 square minus 4 square upon 4 square into 7 square plus 10 square in 10 square minus 7 square upon 7 square into 10 square till infinite. So therefore 3s is equals to, we have 1 upon 1 square, you can say that 1 upon 1 minus 1 upon 4 square plus 1 upon 4 square minus 1 upon 7 square plus 1 upon 7 square minus 1 upon 10 square and so on. So as you can see, all the value other than 1 should be cancelled out till infinite. Okay, therefore here we have 3s is equals to 1 and s is equals to 1 by 3. We got the value s equals to 1 by 3 over here. Here the value is equals to mu, so we can write it, this is equals to mu, correct? This should be equals to mu. Therefore we can write it mod 6 mu plus 2. This is equals to 6 into 1 by 3 plus 2. So therefore we can write mod 2 plus 2. Overall we got 4 and 4 should be the correct answer. So the answer, final answer should be 4 over here. Okay, this is the final answer. Now next question we have two determinant over here, A and 10B. If B is inverse of matrix A, B is what? Inverse of matrix A. Let's try to write B over here. B is equals to 1 by 10. Okay, and let's take transposition of it. So we can write 4 minus 5 1, 2 0 minus 2, 2 alpha 3. Okay, so if I taking transposition again over here, so we got the value. So as we know that if B is your, we can say that if B is inverse of A, correct? So B should be equals to 1 upon determinant of A into adjoint of it, transpose of into your adjoint of A, correct? Equals to what? Adjoint of A. Yes. So adjoint of A is nothing but it is your transpose of all the current cofactor of the given elements. Okay, so we have taken transpose again over here, so it looks like this. So for that case we can say that, let's check for determinant of A over here. So for that we'll get 1 plus 3 plus 1, got plus 1, So 2 plus 3 and plus 1, 2 minus 1. So 4 plus 5 and plus 1, therefore we got here 10. So determinant of A is equals to 10, correct? Determinant of A is equals to 10. Yes. So we satisfy the condition over here. Let's talk about the cofactor of Let's talk about the cofactor of your third row and second column. Talk about the cofactor of third row and second column. This should be actually equals to alpha, correct? This should be actually equals to alpha. Let's write it minus 1 power 3 plus 2 and taking the cofactor of this, so we'll get minus 3 and minus 2. It is equals to alpha, correct? We're taking this minus 3 minus 2. So this is a negative value, this is a minus 5 equals to alpha. So we can say that alpha is equals to 5, correct? Alpha equals to 5. So in that case we have to find the value of alpha. So we can say that the value of alpha is equals to 5. 5 should be the correct answer over here. You can check the solution. So this is the last question for the day. Thank you so much.